Is everybody okay there?
Wait, so then the identity matrix that you augment into it would be 1, 0, 0, and 0.
It would be the same size as the original one, with ones on the main diagonal and zeros everywhere else. It's going to be a 3 by 3 too, yeah. Okay, finding an inverse of a 2 by 2 matrix. Here's another formula. Okay, so for a 2 by 2, you don't do the style that I just gave you. Okay, it's very painful. Instead, here's a formula. Okay, so this is the formula for finding the inverse of a 2 by 2 matrix. Does anybody recognize what AD minus BC is? Anybody recognize that from Algebra 2? From Algebra 2? Starts with a D. Not discriminant, but something sounds like that. DET. Determinant. Who's that? Was that you, Sam? Leah, was that you again? Yeah, nice. Determinant. Okay? And we're going to do determinants tomorrow. Okay? So what I want you to do is I want you to find the inverse of this 2 by 2 matrix that I have there using that formula, and you're also going to check to see that it is indeed the inverse. Okay? So notice how you actually do it, okay? All you do is you find the determinant, which is AD minus BC, and then you might want to look here, okay? You might want to look here. You just interchange, well, maybe I should really write this down. Okay, so this is called the determinant. And more about that tomorrow. But this matrix here becomes essentially you interchange these two guys. Okay, and you make these guys negative. Right? So everybody with me? So that's the kind of visual rule, okay, to see it visually. All right? Right, so can you try your hand at finding the inverse of this 2 by 2 and prove to yourself that it is the inverse, okay? Eileen, did you try to show that they are inverses? Yes.
Yeah.
Both ways?
Yeah.
Yeah, nice. Okay, shall I pause here for a minute? You guys need some time? Yes? Yes, Henry? No, you got it? Is everybody there? Yeah, so first do this inverse. What do you mean by multiply this thing here? What's AD minus BC? So that's minus 1 plus 2, which is a 1. Okay, so you divide by 1, you get 1. You divide it by, say it was a 2, you divide every number in here by 2. Because it's 1 over 2. Okay, so it'd be timesing by a half or dividing by 2. Yeah. Okay? So everybody all right there? Okay. The answer is exactly, isn't this the same matrix that we had before? Negative 1, 2, negative 1, 1. Same as what we had before. It's the same matrix. All right, now why are inverses so important? Okay, why are inverses so important? Well, take a look at this stuff here. It's a lot of math. I'm going to pause here for a minute. Okay. So everybody all right there? Okay. It's like awesome saying you're just going to get this. You should just conclude with that. Okay. All right. I'm going to erase all this stuff because this is really not what I wanted to do. This was just a side. But what I want to show you is where the inverse comes into play. God. Evelina, you're a really, really sick girl. Allergies or maybe allergies? Huh? Oh boy. You sure? Because it might be allergies. My daughter's going through the same thing, and it turns out that she's got allergies because she started taking Claritin and made a huge difference. Okay. All right, now notice what I'm going to do. Okay, this is why the inverse comes into play. If I multiply both sides of the equation by the inverse of A, right? Can I do that? Right? Rules of equations, whatever I do to one side, if I do it to the other side, they still remain equal. Right? Rules of equations. Okay. What does this become? What does this become? An identity matrix. So these are bolded, okay? These are bolded. So now I can't blame Bill Gates on this. Okay? What's I times X? X. What's 1 times 3?
3.
Okay? So I times X is going to be X because I is the identity. It's like the number 1. Okay, so if you times it by that, nothing changes. So then it's saying that X is equal to A inverse times B. So what does the rule say? The rule just says that, okay, how many ways do we have for finding, solving equations, linear equations? We've done so many ways. We did Gaussian elimination to start out with, right? But using X, Y, and Z. Then we did Gaussian elimination using matrices. And then Jordan comes into the picture. Okay, and we get Gauss-Jordan using matrices. And now we get another way, which is finding inverses of matrices. Okay, so what this is saying is that if you've got an equation, a system of equation, you find out its system matrix. This is called a system matrix. You find its inverse and times the right-hand side by that. So don't do this, okay? Don't do this. Why not? Why not? Don't do that. Why not? Why not? What's the technical term? Exactly. Good job, guys. Good job, John. Good job. Awesome. Okay. These two things don't commensurate in that order because this is going to be a 3 by 1. This is a 3 by 3. Are these two numbers the same? Nope. So cannot do that. It's got to be this way.